Hi, this is King of Review. In this problem, we're first told that we're shifting this function y equals 3 times 2 to the x to the right alpha units. When we shift functions to the right, that means we're subtracting a certain number, in this case alpha, inside the function, meaning where the x is. So if we want to shift this function to the right alpha units, the function becomes 3 times 2 to the x minus alpha. And we know that when we do that, we should get y equals 2 to the x. So let's simplify things a little bit. Subtracting exponents is the same thing as dividing their bases. So 3 times 2 to the x minus alpha is 3 times 2 to the x divided by 2 to the alpha. Dividing the bases subtracts the two exponents. This has to be equal to 2 to the x still. So we could divide both sides by 2 to the x, canceling these on both sides, and we get 3 over 2 to the alpha is equal to 1. Multiplying both sides by 2 to the alpha cancels it on the left side, and we get 3 equals, multiplying it on the right gives us 2 to the alpha. Now I'd like to solve for alpha, since I know I'm going to need to use it eventually to find negative alpha times beta, so I need to get rid of the 2. To do this, we can use a log. On the right here, let's put a property, an important property of exponents and logs. If we have some number x to the power y, and that's equal to z, this is the same thing as writing the log base x of z equals y. So, let's see, if I have 2 to the alpha equals 3, that's the same thing as writing log base 2 of 3 is equal to alpha. So now I've solved for alpha. Let's do the same thing for beta. I'm told that if I take the function y equals log base 3 of 2x and I shift it up beta units, meaning I just have to add beta on the end of this log, then I will get y equals the log base 3 of x. Well, I'd like to get a log base 3 of x on both sides so I can cancel them out the way I canceled 2 to the x over here. But to do that, I need to split up the 2x. And we can do that with a property of logs that says the log base b of x times y is equal to the log base b of x plus the log base b of y. Using that over here, we can split up our log into the log base 3 of 2 plus the log base 3 of x plus beta equals log base 3 of x. Subtracting log base 3 of x on both sides leaves us with log base 3 of 2 plus beta equals 0. And if I subtract the log base 3 of 2, I get that beta equals negative log base 3 of 2. Now let's try to find negative alpha times beta. Negative alpha times beta will be, well, beta is negative, alpha is positive. When I multiply those, I'll get a negative, but this negative turns it back into a positive. So I will have positive log base 2 of 3 times log base 3 of 2. It's hard to multiply logs that have different bases, so let's use the change of base formula. If I have the log base b of a, and I'd rather use a base of, let's call it c, I can use this formula, the log base c of a over the log base c of b. I don't really know what base would be easier in this problem, so let's just pick log base 10. That's an easy base. Using the change of base formula, the first fraction turns into log base 10 of 3 over log base 10 of 2. The second one turns into log base 10 of 2 over log base 10 of 3. And now we can see what happens. Log of 3 on the top and the bottom cancel, log of 2 on the top and the bottom cancel, and we are left with 1 over 1, or just 1. So there's our answer. Thanks for watching.